Hi everyone. Today is July 1st, 2021. Welcome to this week's SIG scheduling meeting, and this meeting is being recorded and be uploaded later to YouTube. So today we have only one item in the agenda. So from Vinay, it's about the scheduling support of in place of VPA. So Vinay, if you want, you can share your screen. Let me make you the co-host. One second. Oh, you can share. Okay, great.
Okay, can you see my screen?
Yes.
Okay, great. So, the code review. This is the updated code review. It's based on the previous iteration of this. Was the design changed a little bit. Just to give a brief, let me just go over this here. So the in place. This is the cap number 1287, and I think the main goal with this cap is to, oh sorry, this is not the cap. The cap is this is the cap. So the main thing that we are doing here is we introduced, just to give a summary of what's going on, we make the resources mutable. Previously the resources used to be immutable, so when you create a pod, it is what it is. The resources request never changed for the lifetime of the pod. And the proposal here is to make the resources mutable and then add a couple of fields, status resources allocated, which is what the kubelet agrees it can fit on the node after you change the resources.requests, and status.resources, which is the actual resources that has been applied by the container runtime to the pod's containers. So, and then there is the resize, which gives you a summary status of what's going on with your resize request, which is empty if there is no resize request in the resize has been requested. But if there is a resize that has been requested, then it has 4 different values. In progress is what we most commonly see, where the kubelet accepts the resize, and then it updates the pod status with the resources allocated, saying, okay, let's say you have, for example, resources.request, you're requesting 500 milli CPU, and you that's when you create the pod and you change it to 600. Then this will go from 500 to 600 if kubelet has the capacity has the node allocatable resources to give that to you. And eventually, when the CRI applies that to the container, to the running container, the resources in the status gets updated. So that's a short overview of what this feature really does. The main thing is all this happens without restarting the container. So that helps applications which are not very tolerant to restarts continue to work as the resource needs grow or shrink without having to lose context. Yeah.
I have a question. So these containers that specify the design state, so it's like if we were like a new CPU, how many virtual CPU core or memory, right? Can support both, right? CPU and memory. Is that correct?
Yes. Yeah.
Okay. And then this is allocated, eventually allocated. How about this resource actual usage? It could be much less, right? At different times, even you say I need to change from 500 to 600, but the actual resource could be 100. So does this resources shows the actual resource usage?
No, it does not. So the actual resources usage is gathered through statistics, usually the metrics API, and something like cAdvisor, Prometheus. They are tools that are used to collect that. The driver for this, the consumer for this feature is primarily there's a VPA, vertical pod autoscaler, which is the team based out of Poland, and they manage they have the that vertical pod autoscaler is a tool that you can use to monitor the your pod's actual resource usage. And based on the actual resource usage, it makes recommendations to Kubernetes saying, okay, you have requested um, maybe 2 CPUs, but you're only using 500 milli CPU. How about we resize you to like 600 or 700? They make the recommendations. And today, when they make the recommendation, you have no choice but to restart the pod. And after this feature, they will be able to call the API to update the resources.requests and limits in the future. But today they're only updating the requests and saying, okay, let's size you to 600, or increase your CPU or decrease it based on what your actual usage is. So
Okay.
in the ideal use cases, actual usage should never, the recommended usage or the what you give should not exceed, should not fall below what's being used. And if it does for CPU, then you will run suboptimally for memory. If you're using more, then the API to update, the update container resources CRI API will fail.
Yeah. Okay. Yeah, I'm asking the third field, the resources. You have 1, 2, 3 resources allocated, and there's a resources. So that resources, you say it mentions, it shows the actual resource held by the pod. No, the
Reserve,
next one. No, the
res-
next one. The next one.
yeah, this is the actual resources being enforced on the pod. So
Oh, enforce. Okay, got it.
yeah,
Yeah. So it's not the actual resource usage. Okay. How
it's
about
not.
this resize? Resize?
Resize is just a summary status. This we are familiar with, right? You
Yeah.
had requests and limits here.
Mhm.
So your request is what kubelet you're asking the kubelet or the node to reserve for you, and
Mhm.
limit is if it exceeds that limit. For
Mhm.
guaranteed pods, it's the same, but for burstable, you have, okay, I need minimum of 100 CPU, but maximum of 200.
Mhm.
And then if you exceed 200 CPU, you're capped. If you exceed 200 meg of memory, then you get killed, and your minimum guarantee is 100 M of memory. That is the requests and limits. Resources allocated tracks the requests that the kubelet is able to give you. So if the node has like 4 CPUs and you're requesting 500 milli CPU, uh, and kubelet says, yes, I can give you that. And initially the scheduler does that, right? It sees what the node has, and then based on that, it ranks the nodes based on the fit, and then picks one node. So it doesn't pick a node that does not have the capability to give it 500 milli CPU. It'll pick one that has the uh, capacity. And once you resize, in this case, scheduler is not in the picture. It's a observer. It's a transaction purely between API server and kubelet. But through the updates, the pod cache of the scheduler is also updated. So future pods that come in, it can look at the resources allocated, or do a max of the resources and resources.requests and resources allocated, and schedule pods away from nodes, which is being where the resize is happening.
Okay.
There is a race condition. We had our initial solution that we came up with had scheduler approving the resize first, and then there was a lot of disagreement with that between in SIG node, I think Derek, and they wanted this to be a purely API server versus scheduler transaction versus kubelet transaction. And the justification was, uh, we do support multiple schedulers today, and the node is the final entity that gates what can get in, what is admissible. So we already have the problem of a race condition happening. This should be a rare event, so let's not make it complicated by having scheduler approve first. Let's just deal between the API server and kubelet. And if on some occasion scheduler schedules a pod that reaches before it sees the resize has taken effect, and after the pod gets to the API, the kubelet, after the resize has taken effect, it'll just get rejected, and then it can be rescheduled to another node. The controller will create a new one.
Okay, I see. So this will be directly this resize will be implemented by a direct communication from the API server to kubelet, right? It doesn't go through the scheduler, right?
No, it doesn't. In this
Okay,
case,
it doesn't. Okay, yeah.
yeah,
Uh,
that was the design that we settled with. Initially, we did go through the scheduler, but that did seem fairly complex in the sense that there was an appearance of state being kept across the scheduler and kubelet, and the state was being maintained in the status field, which was not okay because status is supposed to be uh, it should be something that you can generate by looking at observations. They should, like, pod phase is an example of a state that's crept into a status field, and it has been causing problems. So the API conventions now require you don't maintain any kind of state, and it was turning into a state machine. So they did not want that. And this is simpler. And scheduler, in this case, with the change that I have right now, it plays more of a role of assisting. So we can look at the code
yeah.
offline too.
Yeah, so my question, if scheduler is not aware of this resize, right? And later when scheduler get another pod request, it doesn't know, oh, the previous pod, size has been changed. So it could fail to schedule the next pod, right? It could happen, right? If there's a lot of resizing happens. Is there a way that, the kubelet also notify the scheduler about this, resize so that the scheduler can update its, available resources?
Scheduler knows.
Oh,
So
scheduler, okay.
yeah. Whenever a pod is so scheduler receives all pod updates.
Okay.
So whenever a pod is updated, it updates its pod cache. Scheduler is watching for pods, and then when kubelet, let's say the resources.requests goes from 500 milli CPU to 600, kubelet says, yes, I have the capability, I'll update it. So it'll update the resources allocated in the pod status,
Oh, okay,
and
got it.
scheduler sees this,
I see.
and scheduler
So,
sees this as well.
okay, so kubelet will
So
update
many.
that. Okay.
Okay, I have a couple questions. So especially in the resize to make it the request size bigger. So is there any timing problem, say, during the resizing? And so, for example, you request a resize from 1 gigabyte to 2 gigabyte, and during the resizing, and when the scheduler is not aware of the resize container state that resource or resource allocated, and then scheduler put another part to the same node. So can that conflict with the resizing decision in the? So can that happen?
Yeah. Yes, it can.
Yeah.
So there is
That's a race condition, right? It's
scheduler can assign nodes in parallel. If this race condition occurs, kubelet resolves it by rejecting the new pod that it has no room for. So this is the compromise we made. Our initial design was that scheduler approves it, and then kubelet doesn't have to worry about. And kubelet should have the capacity. And even in that case, if you have multiple schedulers, the race condition exists, which is there today as well. So if you have two independent schedulers scheduling to the node, then so they decided it's simpler to have the node just reject the new pod that's coming in. And this should be a rare event. If it does occur, then that pod is rejected, and then what happens to that pod? Of course, it's not in the scope of this KEP, but typically pods are created by some controllers. The controller will see that it doesn't have the requisite number of pods running. It will create a new instance, and hopefully that gets scheduled to a different node.
Yeah. So
which
this
has capability.
Yeah, this sounds a concern to me because this seems to bring the problem that is unique in multi-scheduler to this current single scheduler scenario. So because and as well, a little apart from this topic, the worst thing is that when you schedule a pod, schedule assign the node name, right? So the new pod, as you mentioned here, if it conflicts with the resource allocation, kubelet rejected doesn't mean kubelet reset its spec node name. So that means this pod will be pending forever because it's assumed to be allocated to that node because its no name has been set, right? So kubelet rejects it, but it's still pending out there, waiting for more resources to be allocated for it. Because in this scenario, scheduler is out of the picture. You know what I mean?
Yeah.
So yeah, this is once the conflict happens, the pod will be very likely to be pending there because the resource utilization has been pretty high, and there may have chance or may not have the chance to release the resources in the near future on that node. So yeah, a little bit off the topic is that what I want to pursue is that no matter for multiple scheduler support or for the in place scaling support, I maybe want to idea to for the kubelet to when it rejects the pod, also it reset the node name to empty, so that the pod can go back to the scheduling cycle and find another node instead of okay bypass this pod because its node name has been set. But it's a little bit off the topic. My concern is that now we have the single default scheduler and also multi-scheduler. We both have the potential raising issues here.
Yes, I think it's a good suggestion. We could potentially look at that as an enhancement in the future, because today, resetting the node name, essentially we're talking about a binding sub resource that clears the node name, right? Which is what scheduler are using. So I tried to do something like that initially. I proposed that, but the security folks were not happy with it.
Okay, all right.
Were I actually had in mind, okay, we could do this. We could reset that pod to take care of the race condition. And at that time, we had the kubelet writing to the spec for resources allocated as well. Instead of checkpointing the resources allocated in status, it was part of the spec, because that way, if the kubelet gets resized or kubelet dies, it and comes back up, or the node goes bad, then the state is still there in the source of truth, which is the API server. But I think in the end, it came down to this would be a nice to have. It's not a must. The biggest hurdle there was nodes can be compromised. If nodes are compromised, we don't want to give node permission to write to the spec that easily. So they wanted to control that. So calling the binding sub resource.
Yeah, there can be other options. So for maybe another component, like scheduler, or another component to responsible for resetting this kind of parts.
Correct. That is
because in the before we don't recommend multiple scheduler. It's just because this problem, multiple scheduler can compete for raising the limited resources on the particular node. Then if the conflict happens, it's a big problem, and in practice, it sometimes involves the DevOps team to manually fix this kind of problem. So that is pretty,
that is
ideal.
Yeah, I think in the SIG node discussions, we came up with potential enhancements where scheduler can become smarter about this by looking at not just the resources allocated, but the actual usage, and weighing that in steering the pods towards nodes. That was one of the things that came up. The other thing that came up was having the scheduler see that the pod has reached when it gets rejected, the pod is failed. And if the reason for rejected is out of CPU, out of memory, one of those things, then the scheduler can, instead of letting the pod die, it can reset the binding and then reschedule it. So, but we didn't want to keep it in the scope of this KEP, because this KEP as it is already pretty huge. So if you
exactly,
so
just to want to ensure everyone knows the limitation and
Yeah.
Yeah.
Actually, I have a proposal on how to handle the race condition between multiple schedulers, but I can propose that later. But for
Yeah,
this
maybe
thing,
later. Yeah.
yeah,
For today's meeting, because yeah, we have run a lot of time. So yeah, my another question is, does this support extended resource like
No,
GPU? No. Okay.
no, it's out
Just
of the scope.
core
It's
just
just
a memory
core
just
CPU,
resources.
right?
just CPU. Yeah. So in the scheduler, I think we can see that it does a max when this is just debug prints that I have put in, and the scheduler is this is just to show that scheduler is aware.
Okay. I have a question.
And
Sorry.
to answer, sorry,
No.
to
Okay.
answer the
So
question, yeah.
what is the underlying mechanism that you do the resizing without restart the plot? Is it use C group? You adjust the C group limit, or how did you do this?
Pretty much, yeah. So there are two parts to it. One is adjusting the pod. Since C groups is used for all the tasks that are done, what we do is there is a pod level C group, which is the sum of all the containers resources and requests and limits, requests for CPU, limits for CPU and memory. And first, if the resources are increasing, then we increase the pod level C group requests and limits first, and then call the update container resources CRI API, where the runtime is responsible for resizing the container without restarting. That's a CRI API that's supposed to update the C group configuration without restarting the container. And it's not required, it's not a mandatory thing. Some runtimes may choose, okay, I cannot handle this without restarting. They may internally restart the container. So we don't make guarantees, but what we discovered is, like, at least for Docker and Kata, they are able to resize containers without restarting them.
Okay. So how about GYZ or Firecracker? Do they have to restart, or do you know?
I haven't tried them. I think gvisor should be able to do it without restarting, because they also map C groups, if I recall correctly.
Okay.
Firecracker, I have no clue. I think so. When it comes to memory increases, uh, we've been experimenting in our own internal. There is a project we're working on called Arctos, where we support both native VM and pod scheduling in the same control plane with Kubernetes. And in our experiments, we found that we are able to increase the CPU and increase decrease CPU. It's supported for most VM platforms through the libvirt APIs. And increasing memory works, but decreasing memory is a problem, because once you give memory to a system, taking it away is not. We have to like we were mucking around with some techniques like ballooning and all to see if we can leverage VMs that are underutilizing their memory. So there
Okay.
is a
Yeah.
problem with decreasing memory, but increasing CPU, decreasing CPU, and increasing memory works.
Okay. But decreasing memory, because if they need to reuse that memory, they need to clean it up. So probably more complicated.
Yeah.
But how about the Kata
The,
container? Can Kata container support the decreased memory without restart?
Um, in my experiments, yes, it has worked. In practical usage, I don't know if it works because Kata does the same. It maps the C group settings into the container's runtime. So they're running a miniature VM based on ClearOS, the Intel's solution. It's a combination of that, and I think Hyper, the other company, I forget. So the two of them collaborated and came up with Kata, and they're able to map the C groups from the into the containers, into the Kata containers file system, C group file system. So I found that yes, when you try to uh, decrease the like you try to run some application which exceeds its memory limits, it gets killed, and you increase the C memory, it runs. And of course, if the application is consuming using that memory and you try to decrease it, then the C group it fails. That's just convenient design. So the utilization has to fall before you can decrease it. There is uh, this is the easiest way to uh, see this actually working in practice is to use the memory-backed file systems, memory-backed directories, and where you have the file system is backed by actual memory. So if you create a file and then it's charged to the container's memory, and you try to decrease the C group settings, it fails because that usage is more than what you can decrease it to. You
Yeah.
cannot decrease the limits on that.
How about the
So that's
performance
very
ones? How about the performance? Like, you change the C group. Just how much have you measured that? What's the performance impact for this? Is it
no,
negligible or?
we have not looked at the perf impact of this feature. I think there are places where we might need to do some optimization depending on how often this gets utilized. In the in the node, I think there are places where currently I have had to do some copy the pod, which I think we'll have to uh, slim it down somehow to use just references or something, or optimize the or write a plugin that can do something a little bit differently, as opposed to passing the whole pod to the scheduler, the plugins. But so far, that will be one of the things that we'll look at as we go into beta and see the performance impact.
You
For
just
alpha,
mentioned copy the pod. What do you mean? Why do you're resizing, right? Why do you need to copy the original pod?
for computation purposes, the way the when we call the uh, a check for fit, what we do is we use the original the pod's requested if the pod is if the kubelet is coming up restarting and the pod exists, then we don't want to add it as a new pod. So we check for fit using the existing checkpoint and resources. In that context, we copy it. So when a kubelet restarts, we have to do this additional trickery. But I think that can be optimized away. Besides that, that's the one that occurred to me as a potential thing. Like, but then that should only happen if kubelet restarts. That should be a rare event.
Oh, okay, I see. Restart. Okay, that
Yeah.
happens in. Okay.
Last question, Vinay. So, would you want to pursue it in this release? Because next week will be the code freeze.
Yeah, we are trying to put it for this release. I think the biggest part of the code change that I think Tim Hawken needs to. It depends on what Lantau and that's a kubelet change, and the Tim Hawken see about the scheduler change. If you look at the code itself, so there are the commits that we have in this. I've broken it down into 6 major changes: the API changes in this commit, and the CRI change. I think this is mostly okay. Both API changes and CRI changes are well understood, agreed upon. The kubelet core implementation has not changed much since the last iteration, which was very close to getting approved. And I think Abdullah also looked at the scheduler changes. This is the one with the scheduler resource code, the last commit that's there. The commit itself is I've broken it down so that it's easier to see what changes are involved in here. So in terms of the kubelet, it switches over to reading from the resources allocated, which is what checkpoint, which gets assigned from the checkpoint. And in in the schedule, this is all kubelet changes. So where scheduler would be just this, and I tested this by intentionally delaying the pods, like its evaluation of whether it can fit. So during that time, scheduler will not schedule a pod to that node because of the max, using the max here.
Yeah,
If it is either,
I will review. Yeah, I also think of some other area needs to update it because in recent release we introduced a new theme. So each plugin can register some events so that upon some events scheduler can decide which part to move back to the active queue and which not. So in this case, we made some assumption that the pod status pod request is not mutable. So I need to also check that part.
Oh, okay.
Yeah.
Okay, yeah. Please let me know about that, because then that would mean some more work in the scheduler to check and test. Uh, if it is significant, like this change has been tested in the last release as well, so I have high
Mm-hmm.
confidence in this. The changes that you're mentioning, if that is significant or if it requires a fair amount of testing, then we probably might have to slip it. It's going to be alpha, it's going to be disabled, but
Oh
let's
yeah, yeah,
try and
yeah, yeah.
understand how much of a change that is.
That's okay. Yeah, by the
And
way, my personal suggestion is to split this huge PR into several small PRs so that
I
each PR covers each component like API, like Kubernetes CRI, and then scheduler, and then maybe quarter or something. And so
I
then makes review it from each SIG easier to review it.
yeah, I
And
know. I try.
maybe the PRs has some dependency on each other's, but that will
It
also
does.
easier for the reviewers.
Yeah, I tried to ask this with release management. They didn't agree because and even the API folks were not happy with that because what it boils down to is that let's say I put this in a PR, this gets approved, CRI gets approved. CRI can stand alone by itself, but the CRI change is pretty much meaningless without the feature. It's just, why are we doing it, kind of. If this gets approved and goes in, and the core implementation doesn't come in, then this is meaningless. You'll have to rip it out. So
So
Tim
basically,
Hawkin was
they won't let the pure API changes in, but they will hold the PR there and say LGTM and approve it, and then wait for all the PRs to ready and merge just in one batch. So that is a typical pattern they're doing. Yeah.
okay,
So not
because then I asked release.
basically not necessary. So maybe needs some more efforts from you because in your PR2 you have to keep one commit to be based on the PR1. So for example, PR1 is API change, and then it's like in the last PR you have to rebase each PRs, which is its prerequisite. So that sometimes needs more efforts from the developer, from the author.
Yeah.
It's up to you. I just personal suggestion. Yeah.
No, this is exactly what I'm doing. What you suggested,
Mm-hmm.
even though it's in one PR, because it's a lot easier to manage. I have an API branch in which
Yeah,
I have the
exactly.
API.
Yeah,
I have the CRI, which is
we're
dependent on
based
this
on
branch.
that.
I
Yeah,
have
yeah,
core
yeah.
exactly. I have core implementation which depends on CRI, and then
Mm-hmm.
this is the final staging branch from where I send the PR.
Yeah.
this
Exactly.
this is a complex feature. This is a complex feature. That's why I have to do it this
Yeah.
way. If I do it in one branch, I'm gonna go mad.
Exactly. If it comes to a big feature, involves API, involves a lot of components. Yeah, you have to do this way maybe.
Right.
Yeah.
So yeah,
Anyway,
I would have wanted that.
I will review that, and I will review that the schedule changes. Yeah.
Okay. Yeah. If there are other places where I need to look at in the scheduler, please let
Mm-hmm.
me know quickly so that I
Sure.
can do that change. I'm available over the long weekend to work on this if needed, because this feature has been dragging for a long time and I want to get it in if
Exactly.
possible.
Yes, agree. Yeah.
Yeah. After we have there is a very comprehensive test that I think we have Monchin from IBM who helped with this. So
Yeah, I know her. Yeah.
oh, you know, okay.
Yeah, I
So
know her.
yeah,
Yeah.
the test that we have is very comprehensive. It covers a lot of cases. So
Yeah, that's great.
this gives me a lot of confidence in the feature itself. What remains to be addressed is the performance implications measurement of that and addressing that. And I think there will be some potential changes mostly in the
So
kubelet code.
it's more. I think it's does this end-to-end test that cover more on the kubelet side or on kubelet and the scheduler?
it affects everything because it's doing end to end, and it's measuring. Scheduler for the most part is playing the role of a bystander in this case, and it's assisting with this change. The way I've structured it, there is resize has 4 states: infeasible, deferred, where it's not possible. Infeasible is like if you have a node that has, say, 4 CPUs and you're asking for 5, then it'll never happen. So that is infeasible. Deferred is where, okay, the node has a capacity of 4 CPUs, you're asking for 3, but there's another pod that's consuming 2, and you're at 2, so it's 4. You can get 3 if the other pod exits, then that would be deferred. So in the case of deferred, we would be steering pods away from this node, and essentially, okay, when that node clears up, you will get resized. So scheduler is sort of assisting that in this case. That's how I've picked up to do this. So it's not exactly assisting by like doing getting rid of low priority pods or rescheduling them or something like that. But that's again a future to keep the scope of this. It's already, you can see how many files are there in this change, right? It's huge. So
Yeah.
it's we wanted to scope it. This has to, we have to do this baby steps, and the first baby step itself is so big. It can be enhanced quite a bit. The scheduler we can do a lot of innovation in the scheduler with this, but we just have to take it one step at a time.
Yeah. Yeah, all right. I think we just used 40 minutes to cover one items. Yeah, fortunately there's no other items in the agenda. So yeah, one thing, yeah, one thing I want to call out is that the code freeze date for 122 is July 8th, which is next Thursday. So if you have any items and the PRs are pending, so let me and Abdullah and Aldo know. We'll try our best to review.
Yeah, please do your best. I know this came in, I was planning to have this done quite a bit sooner, but I was stuck with like assisting family situation in India with the COVID and all, and my own schedule got delayed a little bit. So at this point, I'm like hopeful that it can get into one this release.
All right.
But if not, early next release would be just fine.
Yeah.
It's been a couple of years that this has been in the making.
Exactly.
So it can wait another 3 months, I suppose. But if the changes are not risky, then let's hope to get this in.
Yeah. Okay. And before I finish this meeting, so any other items to discuss?
I have a question. So if I would like to propose a scheduler extension, what is the steps or procedures, right? Propose a cap, or how should we?
So basically, if it's an idea that which is unfamiliar or unknown at all to all of us, I would suggest we start with Google Doc. You don't need to care about the formatting. You don't care the stuff. You just list all the ideas and the motivations and background there, and put up a draft design. And so the reviewers and the approvals can take a look and see whether it makes sense. Well, and if it makes sense, we will, okay, so we encourage you to create a formal cap, and then we put more formal reviews on the cap. So this is the standard way to raise up a new feature.
Okay, sounds good. So I create a Google Doc, and then add a discussion item to the meeting, right? To this meeting, and then we discuss it. Okay, I see. Okay, thanks.
All right, and thank you everyone for joining today's meeting. I'll see you in 2 weeks. Right. Thank you for your time.
Okay,
Have a good day.
Okay, bye.